3D. So 3D, as I told you, it is a base of vectors. There are a lot of concepts, there are a lot of interrelated concepts between vectors and 3D. So if you have understood the previous session vectors very well, you should be able to understand this chapter also very well. And I have given you all the important concepts, because all the concepts present in the textbook as far as 3D is concerned are all very important, because everything is formula based. So if you learn all the formulas and if you know how to apply it, then it becomes very easier for you to learn in your exams. The preparation would be very perfect if you learn all the concepts along with the necessary formulas and everything. And also I have given you some important numericals as usual for you guys to practice. So I hope this session is going to be really useful. Now let us go into the session wherein we see all the topics of 3D. Thank you. So, hello, my dear students. In this session, now we are going to see important concepts of three-dimensional geometry. So now let us look over to the chapter. Let us see all the important concepts and numericals related to that. So, 3D geometry. This chapter is full of formulas. So if you remember the formulas correctly, and if you know how to apply it, then it will be very useful for you to understand this concept. It's such a simple chapter, and also the marks are significantly higher. As I told you, determinants and 3D, it is of equal weightage, so you have to give equal importance to this chapter also. It is one of the important chapters. So first we go to the concept of direction cosines, and direction ratios. This is called direction cosines. Short form I am writing. Direction cosines and direction ratios. This we have already learned it in vectors. I already told you while explaining vectors, vector is the base of 3D. So, and the relationship between them. Relationship between cosines and ratios. Direction cosines and direction ratios. So now this is the first topic. So here I'll write L is equal to cos alpha. You all know what is L, M and N. So here for your simple understanding, L, M and N are nothing but DCs. So suppose if you know DCs, the direction cosines, how to find out the ratios? Like for example, ABC or the direction ratios. So now both of them are connected by using the relationship. L is equal to A divided by root of A square plus B square plus C square. And similarly, M equal to B divided by root of A square plus B square plus C square. And N equal to C divided by root of A square plus B square plus C square. We have already learned the relationship in the previous chapter, like L square plus M square plus N square equal to 1. Now if you square and add everything, you will be getting 1, because numerator here it will be A square by A square plus B square plus C square. Root will go away because if you are squaring. And similarly here it will become M square is equal to B square by A square plus B square plus C square. And N square is equal to C square by A square plus B square plus C square. So when you add, everything will be getting cancelled, so you will be getting this relationship, which is L square plus M square plus N square equal to 1. So now this is the relationship connecting between direction cosines and direction ratios. Here L, M and N are nothing but DCs, and A, B and C are nothing but the ratios. So this is one important important concept of this lesson. So now next let us go into equation of a line. Equation of a line, you have many forms. So I'll just tell you a simple formulas. Equation of a line. So here you have two special cases. First is parallel to a vector, a given vector, and passing through a vector. passing through B vector. So there are two types of equations. One is vector equation. Vector equation. So here vector equation for this is given by R vector equal to A vector plus lambda B vector, where lambda is some constant. So A is nothing but the passing vector. I mean uh, parallel to wait. So I have written wrongly here. I'm sorry. Now I will be changing it. Parallel to, I have written it wrongly. So parallel to, it is B vector actually. Parallel to B vector and passing through A vector. Like this it should come. And passing through so equation of a line parallel to a B vector and passing through a given vector A. So for this the formula is R equal to A plus lambda B. So this is a vector equation. Similarly Cartesian equation, which is called Cartesian equation, is x minus x1 by A, that is equal to y minus y1 by B equal to z minus z1 by C. So x minus x1 by A equal to y minus y1 by B equal to z minus z1 by C. So here x1, y1 and z1 are nothing but this is equal to a given passing point A vector, and A, B, C are nothing but, it is nothing but the B vector of here. So parallel to some vectors. So that is what they have given. So here, so this is a formula. Likewise, second formula. The second formula, passing through 2 points. Passing through 2 points, A vector and B vector. So for this, the vector equation is R vector equal to A vector plus lambda into B vector minus A vector. This is small b and this is small a. And Cartesian equation is nothing but, so this is vector equation. And Cartesian equation is x minus x1 by x2 minus x1 equal to y minus y1 by y2 minus y1 equal to z minus z1 by z2 minus z1. So this is the Cartesian equation. So with this equations of line is over. Now let us now go to the next important topic. All these topics are important, so that's why I am discussing all of them. So next concept is nothing but angle between the two lines. Angle between two lines. So if you are given in vector form, suppose for example R vector equal to A1 vector plus lambda B1 vector and R vector equal to A2 vector plus mu times B2 vector. Here lambda and mu are nothing but constants. So if you are given it in vector form, so it is now very easy to find angle, which is you simply have to take the dot product B1 dot B2 dot B2 by mod B1 mod B2. You know how to take the modulus of a vector. So you have to take the dot product B1 dot B2 by mod B1 dot mod B2. It is in fact what we learned formula for cos theta, which is A dot B by mod A mod B. The same formula we'll have to use. And for Cartesian, if they have given it in Cartesian form, this is in vector form. Suppose if they have given it in, if Cartesian equation is given, Cartesian equation is given like x minus x1 by a1 equal to y minus y1 by b1 equal to z minus z1 by c1 and x minus x2 by a2 y minus y2 by b2 z minus z2 by c2. Then the formula for cos theta is a1 a2 plus b1 b2 plus c1 c2 by root of a1 square plus b1 square plus c1 square into root of a2 square plus b2 square plus c2 square. So this is the formula. It is simply nothing but you just have to multiply these two, a1 a2 and b1 b2 and c1 c2, and add everything and take the modulus of this thing, root of a1 square plus b1 square plus c1 square, root of a2 square plus b2 square plus c2 square. So this is the simplest way to remember. Okay, now we will go to the next important concept. This is the final concept of this lesson. After this, we'll go to the numerical part straight away. Now we go to the important thing, which is shortest distance between the two lines. Shortest distance between two lines. So suppose if the two lines are represented by r vector equal to a1 vector plus lambda b1 vector and r vector equal to a2 vector plus lambda b2 vector. So now here you can see b1 and b2 are not same. If they are like this, then they are called skew lines. This is the easy way of identification. For parallel lines, both these b1 and b2 will be equal. So that is how you have to identify. So here it is skew lines. So the distance between the skew lines, which is given by d, which is nothing but modulus of b1 cross b2, b1 vector cross b2 vector dot a2 vector minus a1 vector. As I told you, everything is formula based. So if you know the formula, application of that formula is very simple. So you will have to remember the formula. That is a challenging part here. Divided by modulus of b1 cross b2. So this is the formula to identify, because cross product we have learned it in vectors how to identify, how to find out, and it is nothing but second step is simple subtraction. Then you have to take the dot product of b1 cross b2 and a2 minus a1. Divided by, you have to take the mod and then divide it, so you get the final answer. It's very easy. Suppose if it is parallel lines, r vector equal to a1 plus lambda b. I already told you for parallel lines this b vector will be equal, and r2 vector, r1 vector or r2 vector, which is nothing but a2 vector plus mu times b. So here both of them are same, so from this itself you can say that it is parallel. So d vector equal to b cross a2 minus a1 by mod b. So this is a formula for distance between the parallel lines. Slightly it will change. Okay. Now with this, all the concepts of this lesson are over. Now we'll go to the sums directly. Important numericals. In the numericals part, if you see in the first exercise, you can see, example 2, example 1, and then fourth sum. Example 4 and the fifth sum. So first exercise you need not do at all, because all the sums which we did now are based on the, all the sums from the exercises are based on the examples. You need not do separately once again. So directly we can go to the second exercise sums. In the second exercise, before we go, we'll do the examples. Example 6, and then Example 7, 8. Example 7, 8. Lot of students will neglect examples. Please don't neglect, because examples also carry more number of weightage for your exam. So, and then 9 and 10. 9 and 10. So, second exercise, only few sums we can do. 11.2. First sum. Third. Fifth. 7. 8. 10. 11. 12. 13. And also 15. That's all. Planes are deleted. So planes is deleted topic. So with this, the chapter is over. So this is all these things are very important for your exam point of view. It is enough that if you practice these questions for 3D for your exam. So I hope that this session is very useful for you guys. In the future, we will take up a lot more interesting chapter with lot more interesting questions and also concepts. Thank you. All the very best to you.